Okay, so some of you had questions on simplifying radicals. So I thought we would go through a few examples from suggestions that I got from you. So the first one is taking the fourth root of 80. Okay, now when you simplify radicals, what I want you to remember is that I don't care what multiples you choose, you're going to just choose two numbers, any two numbers that would multiply to 80. Now, it's quite possible that you may choose different numbers than what I would choose here, but the process is the same. It's the length of time that it may take you to get to the correct answer that varies, okay? So, but the process is the same for every single problem. So with this one, if we have the fourth root of 80, I'm just going to write that differently. I'm going to say that that's the same then as saying the fourth root of 40 times the fourth root of 2. Okay. Now, I guess before you even get to that part, one good thing to do is to check to see, can you simplify it using your calculator right off the bat? Can you take the fourth root of 80 and get a number, an integer? And if the answer is no, then we keep breaking it down like I did here in step 2. On your calculator, the way to do this, if you wanted to check, is to type in 80, and then usually you'll see like a caret key. It'll look like that, and then do a parenthesis. And we know that the index is in reference, you can write it as an exponent, right? So I could say 80 to the 1 over 4th power. Make sure you use parentheses. And if you do that, you're going to see that no, it does not just simplify to an integer. So I'm going to continue to break it down. So that leads us back over here. So I've broken it down into the fourth root of 40 times the fourth root of 2. I can't break down the fourth root of 2 any further, but I can break down the fourth root of 40. Okay, so I'm going to go ahead and say, well, okay, that's the fourth root of 20 times the fourth root of 2. Okay, that's where that goes. And then also make sure you carry down what you already had there times the fourth root of 2. And you kind of see how this process works. Again, you can check your numbers as you go. Is there a fourth root of something? You know, if you took the fourth root of 20 in your calculator, do you get an integer out? Okay, so you can check that, but we'll keep breaking it down here. So now I do the fourth root of 10 times the fourth root of 2, because that equals the fourth root of 20. And then carry down what you previously had, fourth root of 2 times the fourth root of 2. Okay. And breaking it down once more, so now I have the fourth root of 5 times the fourth root of 2. And then add in everything else. So then we know we've got 3 more of those. Fourth root of 2. Okay. Now, interesting. You'll notice here that your index is 4, right? We have the fourth root. How many 2's do you have here? I have 4 2's that are to the fourth root, okay? Remember, one way to remember this is that if you have as many radicals as you do your index, we know that that's going to simplify to whatever's inside of your radical. What I mean by that is if you think about writing this as an exponent, remember that's like saying 2 to the 1/4 times 2 to the 1/4 times 2 to the 1/4 times 2 to the 1/4. And what do we do with our exponents when we multiply? Well, you add them, right? So 1/4 plus 1/4 plus 1/4 plus 1/4. Okay, that's going to give you 2 to the 1, which we know is just 2. So that's what all of this here simplifies to. All of that just equals 2. So your final answer, you're going to pull that 2 out front, is just going to be 2 fourth root of 5. Okay? And that is your answer, and that's how we would simplify that down. Now, the problems get obviously a little bit harder. So let's example. Here you have the fourth root of 243, x to the 8th, y to the 10th. Okay, again, the first thing I would do here is see, can you take the fourth root of 243 and get an integer? And if the answer is no, then we want to break it down. Now with bigger numbers, sometimes you're going, well, where do I start? What numbers do I choose? I can tell by looking at this number that it's divisible by 3. 2 plus 4 is 6, plus 3 is 9. 9 is divisible by 3, therefore this whole number is divisible by 3. The other thing I can tell by looking at this is that my index here is obviously 4. And so if you think about breaking your exponents down into multiples of 4 and then simplifying, because again, just a little side note here, we know that we can write this, for example, as x to the 8th, all to the 1/4 power. And then think about using your power rule for exponents. We know that that's equal to x to the 8 over 4, which is x squared. So that I can actually pull out right away. Okay, so let's go ahead and work through this one. So right off the bat, I know I can pull out an x squared. That leaves me with the fourth root of, now I'm going to break down that 243. I'm going to say 3 times the fourth root of 81. And then I'm just going to keep, remember I simplified my x term, but now I'm going to write my y term a little bit differently here. I'm going to say y to the 8th times y squared. Why would I break it down that way? Well, I broke it down that way because 8, remember if you add your exponents here, 8 plus 2 is 10, but I know that 8 is divisible by 4. Okay, and I already know based on what happened with the x term what that can simplify down to. So it's just a matter of practicing and seeing those connections with these. So I always try to break my exponents into multiples of the index as much as possible. Okay, so now with this problem, I know that I have x squared. I'm going to pull out that y squared. And then I have my fourth root of 3. Now look at fourth root of 81. If you go into your calculator and you try to type in 81 to the 1/4 power, it's going to give you the number 3. Okay, so that's what that equals. And then you have the fourth root of y squared left over here. Okay, now we can clean this up a little bit. So one thing you're going to notice with radicals is they get really messy really quick. So I do a little housekeeping usually as I work through these problems. So I'm going to put my 3 on the outside now with the x squared, y squared. Okay, and then what do I have left yet? Well, I have this, which I can't break down anymore. And I have this that I cannot break down anymore. So I just leave that underneath the radical then as 3y squared. Okay, and so that is going to be your final answer for this problem. Okay, so you've got your 3 x squared y squared, the fourth root of 3y squared, and that will be your answer for this one. Okay. Now our last example is something to the 5th root. And with this problem, again, right away, what I notice here is that I've got this 15 up here. Y to the 15th. Y to the 15th, all to the 1/5, is going to be y to the 15 over 5, which is y cubed. Okay. So I can right away, before I even do anything else, I can pull out that y cubed. and rewrite this. Now 96, I don't know what to start with, so I'm just going to choose 2. Okay, I know I can divide it by 2. So let's say I've got my y cubed on the outside, and then the 5th root of 2 times the 5th root of 48. So that's just the 96 being divided here. Now I'm going to break up that x term, and I'm going to say the 5th root of x to the 5th times x squared. Okay? And so right away here again, I see that x to the 5th power. I know I can pull that out. Okay? You would at this point try to say, okay, can I take the 5th root of 48? And simplify if you can, and if you can't, then we have to keep breaking it down. So now I'm going to go ahead, and I've now got on the outside, I have an x, well, y cubed times x, okay? And then I have my 5th root of 2 times, break down that 48. So now you have the 5th root of 24 times the 5th root of 2. And at the very end here, we still have that 5th root of x squared, okay, hanging out. I can't reduce that one anymore, so that one is just one I have to make sure that I write down each time. Again, you'd see, can I take the 5th root of 24? The answer is no. So now it's just breaking down that number as much as you can. Okay, so you can choose how you want to do this, but I just am going to keep using 2. So I'm going to say y cubed times x, and now I have the 5th root of 2. I'm going to put all my 2's out front. 5th root of 2. Okay, now I'm going to break down that 24. So I'm going to say the 5th root of 12 times the 5th root of 2 times the 5th root of x squared. Okay, and you just keep working through that process. So each time you reduce, you can see I'm moving my 2's out front here. And now we break down the 12. So I'm going to say the 5th root of 6 times the 5th root of 2. And then, of course, we still have that x squared on the outside. I apologize for the handwriting. It's a little hard with the stylus with those roots. Okay, so break it down one more time. So the 5th root of 2 times the 5th root of 2 times the 5th root of 2 times the 5th root of 2. I now have 4 of them. Okay, and now I'm going to break down the 5th root of 6. So I'm going to say the 5th root of 3 times the 5th root of 2 times the 5th root of x squared. Okay, so at this point it looks very messy, but what I want you to do here is now we've simplified everything as far down as we possibly can. If we have 5 2's, then I know I can pull that out. So there's 1, 2, 3, 4, 5. Okay, so now I know I can pull out a 2. So I have 2y cubed x. And then what is going to be left on my inside? Well, it'll be the 5th root of, we have a 3. So that's left, and that's left. So 3x squared on the inside. Okay, and then this will be your answer for that one. So I hope that this helps, and as we move through these radicals, I think it's important for you to remember that there are lots of different approaches that one can take. This is simply one way of doing it. It doesn't mean that it's better than any other way. It's just a way that I use that I think makes sense, but certainly you are very open and welcome to try other techniques as well. So let me know if I can be of more help.